like I was saying, when I drop these box things and stuff, I want you guys to make sure you put them in on that progression sheet, because that's something you guys will be allowed to use. That way you have it. Also, the idea of using this sheet kind of helps you as you get going into proof stuff. So many times students will go, I don't know what to do, I don't know how to start. Well, this is where you start. You start by looking at these boxes and figure out what you work on. For example, one thing that we haven't done as far as proofs yet is dealing with segments. One of the most common things we do with segments is this. If given a midpoint. So the reason why I'm saying it as if given, because remember when you're dealing with proofs, you're going to have, usually you'll have some sort of a given and a proof statement, just like we do with the algebra. I don't know why I was drawing this. And then there'll be a diagram. So if they give you that you have a midpoint, what can you say if you have a midpoint? What do you know? What is midpoint? Let me rephrase that. What does a midpoint do? Cuts it in half equally. Cuts what in equally? The segments. So that means you get two segments that are equal to each other, two segments that are congruent. So what you do is you would state either segment congruent to segment or segment equal to segment. Reason why I'm writing both of those is because remember when we did the algebra, all the stuff we did in algebra was with equal signs, but as we get into like triangles and some other stuff, we'll be using congruent symbols. They're interchangeable when we're dealing with proofs, okay? Except when you have to switch. Remember, we did that one earlier. So here's what an example would look like. Excuse me. For example, if you are given the information that B is a midpoint of XY. If I were to be using this in a proof, my statements and reasons, I would obviously just state the given, B is the midpoint of XY. And then if I look at my diagram, what are the two segments that are created that are equal to each other? Well, XY is the whole thing. So what are if B is the midpoint on XY, what are the two segments that are equal now? Yep, that means in my diagram I can do this. XB and BY are the same. So I would write XB congruent to BY. And my reason is definition of a midpoint. That's it. And if you wanted to use equal, you could write equal. And you'll see today, since we're doing a lot of algebra stuff, most of the things we're going to do with algebra, we'll use the equal symbol. But if you have congruent there, you can do that as well. And that'll come up when we do triangles in a couple of weeks. Okay? Extremely straightforward. There's really nothing messing with you there. Okay? It's stuff that you knew. It's just now how do we write it out? Okay? Not bad. Excuse me. The other one that you'll see pretty regularly alongside this one, if you're given midpoint, is sometimes you're given a segment bisector. So we'll do that one. I don't want to get too far ahead of anybody. Everybody got this one okay? Another one we'll do. Sometimes we might be given a segment bisector. What do you think a segment bisector does? Don't say bisects a segment. How many parts? I'm sorry, how many, are they equal or are they not equal? Which is it? Now they're equal. Remember, a bisector cuts something into two equal spots. What's that? Same thing. Okay? You're basically doing the same thing. Segment bisectors just don't have to be a midpoint. They could be a ray, they could be a line, they could be anything. What happens, again, you would state segment congruent segment. Or if you wanted to write segment equal segment. It just depends on the setup that you're doing. What is XB in this picture? What is XB? It's a ray. Okay. XB in this case is a ray. I wanted to make sure you guys saw something like this because sometimes they will show rays, they might show segments, they might show lines. Anything can be a bisector of a segment. Then it just kind of falls through the same way as a midpoint. So if you're given that XB is the bisector of AC, the two segments that are congruent then would be what? Yep. Sometimes it might just say it's a bisector. Sometimes it might say it's the second bisector. It'll be up to you to figure out if you're bisecting a segment or you're bisecting an angle, because your reason would be different. So, just like we said, AB. Your reasons are usually going to be definitions. A lot of times, the statements that you put down, in this case, XB is a bisector, there's something you can do with it. There's some definition that goes along with the word bisector. Like with midpoint, something that has the definition of a midpoint. Okay? You utilize them to make your next steps. That's why we call it a progression sheet, because it tells you what goes after, what comes next, what comes next, what comes next. Okay? That's the way we work these things through. I'm trying to remember, on your sheets you had vertical angles, we had reflexive, midpoints, switch. Here's another one I want to put out there. This isn't the actual progression, but remember how we did the ones where we put little asterisks and we said look for vertical angles, we do like the bow tie. Look for the reflexive side, something that's shared. We'll do another one like that. And call this I want to put an example of what segment addition looks like. Easier. Segment addition, in order to add segments together, what do all their points have to be? Talked about this one a long time ago. What's that? When you have your points, if you're going to add things together on a line segment, the points have to be on the line segment. What is that called when all the points are on the line? Collinear, yeah. So what I'm talking about here is these things have to be collinear. It's just, you don't really have to say that, but I'm assuming you guys have kind of figured that out. So here's what happens. Segment addition is when you take two smaller segments and they add to equal a larger. What are the two smaller segments in this one? X, Y, and Y, Z. Add those two together, what do you get? There you go. It's one of those things that people tend to forget. You're just adding segments together. Speaking of addition, what is 2 plus 2 plus 2 plus 2? 8. Okay. What is 2 plus 2 plus 2 plus 2 plus 2? So what's an easier way of saying 2 plus 2 plus 2 plus 2 plus 2? 2 times 5, right? Is it multiplication, repeated addition? Okay. So reason why I say that is since that we haven't really done anything yet as far as proofs are concerned, only thing we know how to do really is two smaller segments added to a larger. We know that midpoints happen. Same thing with angles. As we get going into it, we know that two smaller angles make a larger. We have an angle bisector, kind of similar to what a segment midpoint is. But one of the things we'll start to see here is this idea of repeated addition. For example, if I said AB plus AB plus AB, what would that equal? That's what you're multiplying. How many ABs are there? So how many am I adding together? 3 of them. So if AB happened to be 5 feet, what would all 3 of them add up to equal? 15. So you did 3 times 5, right? So isn't this the same thing as saying 3 times AB? AB plus AB plus AB, there's 3 of them, right? 3 times AB, same idea. This is just definition of multiplication. That's what multiplication is. It's repeated addition. You can do this oops, sorry. I can do this because of the definition of multiplication. Okay. And it works going the other way too. If it was AB plus AB, that would equal what? 2AB, yeah. Right. Remember, you can go the other way. If it was 4AB, and I wanted to rewrite that in terms of addition, what would I do? Yeah. They work back and forth. This is something that shows up pretty regularly, especially this week, because you don't know how to do much of anything else yet. All we really know, or we are going to really work on, is just adding, subtracting, midpoint stuff, and so on and so on. Okay. I just want to make sure you guys saw that one, because I know we're going to use it here. Not terrible? Well then, let's do a proof. there's a given and a proof statement here. And a diagram that goes along with it. So when we do proofs, what I want you guys to start looking at is, before you start going in and drawing up your two columns, excuse me, I want you guys to look at what they give you. I want you to look at the diagram, see if there's things you can mark because of what they give you. And then what are you trying to show in the end? Notice any similarities, any differences, and even think about, okay, how did they get that? What can I show? So remember, you really only know a few things. Right? So in this problem here, it says that AD, segment AD is equal to 2AB plus BC. Well, what does 2AB stand for again? It's just two of them. Yeah, AB plus AB. It's just condensed. Okay? Multiplication is repeated addition. And at the end, they want to show that AB is congruent to CD. Now, right away, everybody notice that they start stuff in equal, but how do they finish it? Congruent. All of the properties that we deal with when we're doing math, like adding, subtracting, that kind of stuff, there's always an equality. But at the end, they probably just use, remember on the progression sheet, we have that thing that says definition of congruency? They just flipped it at the end. Okay, so you know somewhere along the lines you have to use that step. Little things like that you start to pick up on. So they give you that idea that AD is 2AB plus BC. So you're looking at it, oh, okay. So start thinking about writing it down. That's given to me. According to the diagram, though, what else is AD equal to? The diagram. What is AD made up of? AB, BC plus CD. If you look at the diagram, I also know that AD is AB, BC, CD. And why can I add three smaller segments to get a larger? What property did you just use? Segment addition. Okay. Or I should say property reason. It was segment addition. When you have two things that equal other things, excuse me, rephrase that. When two things that are equal, that equal other things, don't those two things have to equal each other? How about this? Do you see an AD here? Do you see an AD here? Does AD equal AD? You are always yourself, which means, shouldn't those two things have to equal each other? When you put something in for something else, what are you using? Substitution. You're going to see a lot of that, especially this week. You know that when two equal things equal other things, the other things are equal. It just so happens there's a lot of letters. You can put one in for each other. And now you're at the point where you have same things on both sides. They're not numbers in this case, they're letters. What do you see that's the same on both sides of the equal sign? BC. How do I get rid of it? Subtract it. Very good. Yeah. So if you're subtracting the same thing on both sides of an equal sign, what property are you using? Say it louder, you got it right. Yeah. That was the whole point of doing all those algebra problems before with those proofs. By doing those step-by-step ones. By writing out the algebra, now you see this stuff. There's just no numbers. Okay? When you rewrite something, what are you doing? Very good, very good. So when I rewrite this, okay. What can I do with that 2AB then? Yeah, you could do that one, but this is where proofs get a little fickle. They don't want you just to subtract that over like you would like a variable. You know how if it's like a 2x and a 1x? They want you to split this like that. Break it into 2. Then you would subtract it out. That's why I showed you guys that definition of multiplication. Okay? A lot of times, and I know algebraically you guys would just subtract 1 over and you would drop it. When they get the proofs, you have to be extraordinarily specific about everything. So you have to show that little step. So if you do that, now in this case here, by splitting it apart from the multiplication to an addition, that's just the definition of multiplication. Because when you rewrite it from here to here, you're using the definition of multiplication. Because of the repeated addition. If it was 7AB, I'd have AB, 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 all with plus signs. Just plus signs. Now do you have the same thing on both sides of the equal sign? What do you do? What's left then? AB equals CD. What did we do? Oh, we already did that. We wrote out what we did. We're not saying like x is 2. We just rewrote, so it's simplify again. Okay. Now I gotta go back up here for a second. We've shown what they wanted us to see, except what? Congruent. So my very last thing then is to do what? Perfect. I would just rewrite it one more time because of the definition. That's proof. It has to be, it's a lot, yes, I agree. But was it tough? No. It's just you're justifying your steps like you did with the algebra. But instead of using x equals 2, you're doing a bunch of letters. Okay? Segments are really, really straightforward. Same thing with angles when we get into them. The only difference tomorrow with the angles, you just have more letters. As angles use 3 letters versus segments using 2. Excuse me. All right, let's try another one. I'll do this one last. Okay. Let's do one with the midpoint. B is the midpoint on AC. And then it wants us to show that AB plus CD is B. So as you start looking at it, the first thing you're talking about is the segment AC. But the last thing you're talking about is the segment B. You got to figure out how are those two related. Well, before we get going too far, does AC, the segment AC and the segment BE have anything in common? segment AC, then you have segment BD. AB, BD. Do they have something in common? What do they have in common? What? B. Segment AC is this guy right here. Segment BD is this guy. What do those two segments have in common? BC. That BC is in both of them. Okay? That's what I mean by looking at what they share, because we have to figure out how do we talk about some of the overlaps. Right? So if we go back to the original, where we were given B is the midpoint. So in my diagram, what two segments have to be equal to each other? If B is the midpoint of AC, that means these two have to be the same. When you go to your progression sheet, what did it tell you to do if you're given a midpoint? It says to do what? State the segment congruent segment, or segment equal segment, right? That's what it says to do. So should I use equal or congruent here, you think? Take a guess. What do you think? Equal, why? Oh, but remember, you have the choice. You can say equal or you can say congruent. Why are you choosing to say equal? You're right, but why? Okay, you got a 50-50 chance. Why is he right? What are you trying to show? That they're equal. So use equal. All right, when we did the other one, we had to start with equal because you were given equal. We had to finish it with congruent. Here it just says go to equal. Okay, so you stay equal. So AB equals BC. Definition of a midpoint. That's what the sheet says. You follow what it says. Now, if I go back up and look at my diagram, that one segment didn't really, that AC doesn't really get me too far. But I have to talk about BD. What is segment BD made up of? I know that BD is made up of BC and CD. What tells you that you can add two smaller segments to make a larger? There's your reason. Okay. Aren't those two the same? So when I have two things that are the same thing, I can rewrite what's BC have to equal. AB, right? So anywhere I see a BC, I can replace it with AB. What did I do? Put something in for something else. Are we done? Yeah. Is it okay that BD's on the other side of the equal sign? Yeah, that's okay. That's all right. I'm not really worried about rewriting it and going back the other way. That's not a big deal. Okay? It's fine. That's all it is. You used a definition and a substitution. Pretty much all of these are definitions and substitutions. Okay? It wasn't bad. You'll see the exact same thing with an angle tomorrow when we talk about angle bisectors. It's just more letters. Let's try this one. So B is between A and B, C is between A and B. All that is telling you is that they're all collinear. It's the same thing as saying A, B, C, D are all collinear. They just wrote it out differently. B is between A and B, C is between A and B. Okay? Normally, what we would do is if you have multiple given steps, if you will, you would write each one of them and then say something about it. Write it, say something about it. For example, if it said, you know, B is the midpoint of x, y, and the next one was C is the midpoint of ZC or ZD or whatever, you would write out two different steps, you'd write out two different next statements using definitions and so on and so on. The reason why we do that is eventually when we get 3 or 4 different given statements, you don't miss something. You don't accidentally skip something out of the progression. Here, there's really nothing you can do, just knowing that all this is telling you is that all the points are on the same line. That's all that means. All right? So we have to look at what they're trying to prove. They're trying to prove that AB plus BD is the same thing as AC plus CD. So look at what they're doing. AB plus BD, AC, and CD. Okay? Well, what does AB plus BD have to equal? Correct. If you look at it, as you start going back and forth between pictures, well, AD is AB plus BD. What did you do? Perfect. Just filling it in. Okay. Isn't AD also AC plus CD? Look at the picture. Isn't that the same thing? Two smaller segments added to equal to large? Take a wild and crazy guess what your next step is. Substitution. And what do you substitute? No, you're thinking too hard. Aren't those two things that equal AD? So don't those two things have to equal each other? That's all it is. That is just straightforward substitution. When two things equal the same thing, they equal each other. putting in something for something else, or when two things equal the same thing. Get that? I think we have that on our. I think we have that on our, what do you call it? That reason bank, correct? What substitution was? I hope so. So if it's not on there, make sure you have your substitution, what it looks like. When two things equal the same thing, they equal each other. Or put something in for something else. That's what that looks like. Okay. There's going to be a lot of switching back and forth between sheets, guys. There's no, this stuff is, we've made these things, or I should say, I've made these things over the past few years just to make sure you guys have all the info you need to do these things and not just go, I don't get it. Because this stuff tells you what to do. It tells you where your steps are. All you have to do is just read it. Okay? All you got to do is read it. We got time to start this last one. Oops. There, we got time to start this next one real quick. Guys, come on, write this down. We got time. You're given two different midpoints, and at the end you want to prove that something is something else times 2. When you multiply something, that just meant you had repeated addition. So you had to figure out how do we write these things out in terms of addition. Oh, there's segments. That means there's probably going to be what? Probably going to be some segment addition. Okay. So according to your progression sheet, what is the first thing you would do after you know that you have a midpoint? What would you say? If M's the midpoint of AB, what does your progression sheet tell you that you should do next? State the equal segments, okay? So if I'm looking at my diagram, if M's the midpoint of AB, according to my diagram, then that means that AM and MB are the same. So I write it down. Again, why am I using equal and not congruent? They didn't just start with it, but it ends with it. Okay. Definition of a midpoint. Have I used up that full given? That first statement, that first given statement. Yeah. So then I go to the next one. This is why we always write them out separately, because sometimes you'll forget that you might forget to write something down. If you put both of those two givens next to each other, you might only do the one of the segments. You might not do both. So you have to go to the next one. Okay. According to the diagram, if B's the midpoint of MD, what two segments are now equal? Right. MB already has one tick mark, so how many tick marks does BD get? 1. So we're just using our diagrams to get going. Okay. Now, excuse me. They want us to talk about segment MD. What is MD made up of? Okay. What says that? What tells you can say that? Segmentation. So we know that MD is MB plus BD. I want to write it in terms of just MBs, which means how many MBs do I have to have in that statement? 2 of them, right?
Yeah.
So what do I have to do with BD? Perfect. Well, I'm going to run out of time here, but there's your substitution. The last step would just be what? What would the last step be? That's simplified. When you have repeated addition, you rewrite it and you write it as multiplication. What is it? Yeah, definition multiplication. Could you say multiplication definition if you want? Yeah, it's the same thing. Definition multiplication definition works for you. So this packet that I'm giving you guys now has got a bunch of stuff that we're going to be doing over the course of the next few days. So don't lose this thing. But we're not, for today, I only want to do a couple of these, so I'll write this down real quick. On page 1, the bottom, so, thank you. I know there's probably a ton of extras lying around. So, on the different pages, on the first page, there's an algebra 1 at the bottom. That's what I mean by that. On the second page, there's one at the bottom. And then on the third page, there's the top 2. Basically stuff that has segments in it. We haven't done any angle stuff. I didn't want to get you guys too far into angles yet. We got a lot of progressions. Okay? What's that? So, I couldn't find the originals. This one had an answer key to it, and I did my best to kind of white it all out. It just didn't look as great as that box, but, you know, I understand. Okay? So, there's 4 of them. 3 of them are fill in the blank. 1 of them is on your own. Okay, so don't overthink it, and you're going to be fine. We'll get to the angle stuff tomorrow. We'll talk about complementary, supplementary, right angles, linear pairs, perpendicular, angle bisectors. There's a ton of progressions with those. All 4 of those. Not yet. Just write this down. Yes. They're not